Hello everyone. In this lecture we'll see one of the important problem based on analytic function. A problem is, if f of z is analytic, show that bracket dou square upon dou x square plus dou square upon dou y square of modulus of f of z whole square is equal to 4 times modulus of f dash of z whole square. So this is nothing but dou square upon dou x square plus dou square upon dou y square. This is nothing but a harmonic property here. So we'll see the harmonic property of f z whole square will be out here 4 times f dash of z whole square. The solution. We'll consider for f of z. So let f of z is equal to what here? U plus iv. Be analytic. We'll consider, so f of z is equal to u plus iv is analytic. Then take the mod, that is mod of f of z is equal to, if you take mod of this, so mod of u plus iv will become square root of u square plus v square. So be careful here. If you take mod on both sides, so mod of z is equal to square, it will become out here square root of u square plus v square. Or so I don't want this square root, so squaring on both sides, squaring on both sides. So if you square on both sides, we'll get mod f of z whole square is equal to, so square and root get cancelled, we are going to left here u square plus v square. So once we get this u square plus v square, we'll consider this u square plus v square is nothing but some function phi. We'll consider for this. So we'll say, so phi is nothing but u square plus v square, or f dash f of z of modulus of f z whole square is nothing but also phi here. So we'll see whenever it is required, we'll use u square plus v square is equal to phi, or phi is nothing but u square plus v square. Now to prove that bracket of dou square upon dou x square plus dou square upon dou y square of what here, so in the question what we have, so this dou square upon dou x square plus dou square upon dou y square of modulus of f dash of modulus of f of z of whole square, which is nothing but, so we have taken it is as either u square plus v square or phi. So in place of this modulus of f z whole square, I will write phi of phi equal to 4 times the right hand side here, 4 times modulus of f dash of z of whole square, modulus of f dash of z whole square. We'll see now here, this is a statement, but just I have changed what is here modulus of f z whole square instead that by phi here. Now so to prove this, what we'll do here, so to prove this, we will take it as, if you prove this much, that is to prove phi xx plus phi yy equal to 4 times modulus of f dash of z of whole square, it is enough here. So now we'll see here, if you prove this double partial derivative of phi xx plus double partial derivative of phi of yy, that is double derivative of phi with respect to x and plus double derivative of phi with respect to y. If you show this answer, it is nothing but we have proved this. So now we'll see here, consider phi is equal to u square plus v square. So for this we'll differentiate. So differentiate with respect to x partially. So if you differentiate phi with respect to x, differentiate phi with respect to x partially, means what happens here? So phi x is equal to, so u square, partial derivative of u square with respect to x will be 2u into ux plus partial derivative of v, because u and v are again function of x and y, so you have to consider like that. So partial derivative of u square is 2u into ux plus partial derivative of v square, it is they are not constant, okay, because they are functions of x and y. So partial derivative of v square is 2 times v of vx. So if you take 2 common among this, so we'll get ux plus vx. So give equation number 1 for this. Now similarly, differentiate phi again with respect to x. We want a double derivative. So again now differentiate phi with respect, differentiate phi again with respect to x partially. So what happens to the result here? So the result number 1 we have differentiate. So you differentiate this part, it will become phi x is equal to, or else we'll differentiate this. So 2 will keep outside. So here we have to go for product formula for this as well as this. So keep u as it is. Partial derivative of ux with respect to x is uxx plus keep ux as it is. Partial derivative of u with respect to x is ux. This plus sign, again product formula, keep v as it is. Partial derivative of vx is vxx plus keep vx as it is. Partial derivative of v with respect to x is vx. So on simplification, phi of xx is equal to 2 into u into uxx plus ux into ux will become ux square plus v into vxx, vx into vx is vx square. So we'll give this as, instead of this one, I will give this as equation number 1. Now differentiate this phi with respect to y partially now. Similarly differentiate. So actually this is a symmetric function. So symmetric function means what here? X will be replaced by y and y is replaced by x. So directly I will write similarly y phi of yy. If you differentiate phi with respect to y partially one time and 2 times, so at that time we will get partial derivative of partial derivative of yy, that is double derivative of phi with partially with respect to y will be, directly I am writing. So u will be converted as x, x will be converted as y here. So just see, so 2 as it is, this u as it is, uxx will become uyy plus ux square will become uy square and plus v into vxx will become vyy plus vx square will become vy square, because these are the symmetric this function. So therefore we can write this one as directly and give equation number 2. Now we have to go for adding 1 and 2. Adding 1 and 2. So left hand side add with left hand side and right hand side add with right hand side. So adding left hand side, that is phi xx plus phi yy, that is left hand side. So left hand side add with left hand side is equal to right hand side. So on adding right hand side, that is 2 times u into uxx plus ux square plus v into vxx plus this vx square plus continuation plus I will write down here. So right hand side of equation 2, that is 2 times u of uyy plus uy square plus v into vyy plus vy square. So on rearrangement, phi of xx plus phi of yy is equal to, take 2 common, so we are going to left inside u of uxx plus ux square plus v of vxx plus vx square plus u of uyy plus uy square plus v of vyy plus vy square. Now, since f of z is analytic, then always remember u and v are harmonic. If they are analytic, they are harmonic also. And so therefore, hence we know that, hence uxx plus uyy will be 0 and vxx plus vyy is also 0. Also by CR equation, ux is nothing but vy and vx is nothing but minus times uy. So using these condition, okay, so the above expression will write it here, phi of xx plus phi of yy is equal to 2 times, so you just see here among these two, if you take u common, so what happens here, uxx plus uyy, so among these two terms if you take u common, so we'll get this, fine, plus again among these two I will take v common, so it will be vxx plus vyy, fine. Then we are going to left with this ux square, vx square, uy square and vy square. So I will write this ux square, so ux is vy, then ux square will become vy square. Okay, so this part I will write vy square by CR equation, and or else this ux square will keep as it is. So ux square will keep as it is, plus vx square will keep as it is right now, plus uy square plus this vy square. Now in the next step, phi of xx plus phi of yy is equal to 2 times u into uxx plus uyy, as per the identity it is 0, that is u into 0 plus v into 0 plus ux square as it is plus this vx square as it is plus this uy square. So this uy square, so uy is nothing but, so shift this minus sign here, so it will become minus vx. So this uy square I will write minus times vx square, because uy is going to replace by v, minus times vx, so this uy whole square you can consider, uy whole square you can consider as what here, the minus times vx whole square plus this Vy square, so Vy is nothing but Ux, so I will write this one as Ux whole square. So on further simplification, phi of xx plus phi of yy is equal to 2 times u into 0, leave it, plus v into 0, this also leave it, so ux square plus vx square plus into minus, so minus times vx whole square will become plus times vx whole vx square, and ux whole square will become ux square, which is nothing but 2 times ux square plus ux square will become 2 times ux square, vx square plus vx square will become 2 times vx square. So take 2 common, phi x plus phi y is equal to, if you take 2 common, 4 into 2, 2 into 2 will become 4 times ux square plus vx square. So we got this result. So this result number 4 I will give. But we know one of the important result, f dash of z is always given by ux plus I times vx. So therefore, if you take mod on both sides, so mod of f dash of z will be square root of ux square plus vx square, if you take the mod. But I don't want this square root, means square root squaring on both sides, squaring on both sides. So we'll get mod of f dash of z square is equal to ux square plus vx square. So I will give this as phi. So right hand side ux square plus vx square, we have here in the 4 ux square plus vx square, so we can write 4 times the left hand side. So using phi in 4, we get, means phi xx plus phi yy is equal to 4 times this, instead of ux square plus vx square, we can write what here, modulus of f dash of z of whole square here. Therefore 4 becomes phi of xx plus phi of yy is equal to 4 times f dash of z whole square, so which is nothing but what here. So if you prove this, already we have soon seen in the statement I have given. What is that statement? I will show that one. So if we prove this result, so if you shift this phi inside here, so it will become dou square phi upon dou x square. So dou square phi upon dou x square is nothing but phi xx, and if you multiply this phi here, so dou square phi upon dou y square will become dou phi of yy. So phi xx plus phi yy, this is nothing but this result we have to prove. So the same result we have proved now here. So therefore I can say that, so dou square phi upon dou x square plus, this is nothing but, so dou square phi upon dou y square is nothing but 4 times modulus of f dash of z whole square, so which implies dou square upon dou x square plus dou square upon dou y square of, I have taken phi common, 4 times f dash of z whole square, which implies dou square upon dou x square plus dou square upon dou y square is equal to, phi is nothing but modulus of f of z whole square, which is equal to 4 times f dash of z whole square. So hence the required result. So one of the important property of the analytic function.